this shape looks like, but the question is, where will this shape be? Well, I know that I have a horizontal asymptote at y equals 1. So the shape that I'm looking for is going to be a shape kind of like this. And I need to make sure that my horizontal asymptote here is going into play. And so I know that my picture is going to look something like this. Concave up and increasing. And in order for my horizontal asymptote to be a horizontal asymptote, I need for this part that's leveling off to level off at y equals 1. So that's how I know to put this portion of my picture up in this upper left-hand corner. Okay? And the same idea is going to happen over here. When x goes from 1 off to infinity, we're looking at decreasing f, still concave up. So my picture is going to look something like this. So all of this information gives us this picture of f. All right, we now know all the minute and important details of this function. We were able to sketch it based on f prime and f double prime. Are there any questions about that? Okay, so this was a good one to look at because it encompassed everything that we talked about in section 4.3 as well as the vertical and horizontal asymptotes from prior sections. Okay.
So because we've got those continuous lines on either side of plus or minus 1, yes.
These two?
Yeah, we don't say that we have any sort of local max or min there because...
That's right, because this continues to go upwards forever. There's no point where in any sort of a window the point is the highest point, and the same with the lowest point. So yeah, so there is a local max. Now this local maximum is not an absolute maximum because there are y values that are larger, but at least within this little window right there, that is the highest point. Okay, so that was number 35, bear of a problem. Please take your 10-minute break.